Okay, today we're going to be doing 5.3, which is properties of definite integrals. So a lot of these are kind of, I don't want to say common sense, but you could probably have figured out what they are. But essentially, if any integral has the same boundary on the top and the bottom, it's always 0, because of course if you're plugging some number in and subtracting it from the same thing, anything minus itself is always 0. So that's an important one to know. That's one people kind of overlook and forget about a lot. Just like with the derivatives, all the stuff that is with 0 is one that people always forget. So keep it in mind. The order of integration. So if you're integrating from a to b, and you decide to switch it and integrate from b to a, it maintains most of the same integral qualities except for the fact that it's going to become negative. So if the answer to this was 4, the answer to this would be? Negative 4. Constant multiple. So if you have a multiple out front, you can bring it outside because it doesn't affect the integral in any way, just like with derivatives. So if you have a coefficient of, like, say 4, like 4x, you can do the integral of just x and multiply it by 4. It'd be the same thing as doing the integral of 4x, essentially. So you can factor out a constant multiple, like a number. Sum and difference, whether it be sum or difference, if you have like x squared minus x, if you break it up into two integrals, like the integral from a to b of x squared plus the integral from a to b of x, it's going to give you the same result as if you did it all in one integral. Lastly is additivity. Additivity is a little bit more difficult to understand, so I'm going to zoom in. So all it's saying is if you have an integral that goes from a to b, it can also be rewritten as the same thing but with smaller intervals. So for example, this interval here goes from a to b, and within it we have a point c. So that means if we go from a to c and we add it to the integral from c to b, it's going to be the same thing as going the entire way at first, right? So it's just like kind of like the segment addition rule in geometry. Kind of same idea. All right. There is one last kind of like mini property I'm going to add in here at the end. You can feel free to add it too. It says change in variable. I kind of realized it came up on the homework and we hadn't put it on here. So change in variable goes like this. If you have a function that you're taking the integral of, like f of x dx, you can change it to f of z, f of t. The thing you have to make sure you do is if you're going to change it, you have to change the function's variable throughout, and if it's dx, you got to change it to whatever the new variable is. Because, for example, if I took a function, you don't have to write this part, like x squared plus x, and I changed it to 4t squared plus t, it's going to give you the same result. It's the same thing. But if I only changed it to 4t squared plus x, that's no longer the same thing, right? If you're going to change the variables, you have to do it consistently throughout the problem. Does that make sense to everybody, what I'm saying by that? Okay, just making sure. Okay, so it is kind of common sense for sure. There are a few on here that I think it's useful to see. But for example, suppose that we know that the integral of f from -1 to 1 is equal to 5. The integral from 1 to 4 of f of x is equal to -2, and the integral of -1 or g of x from -1 to 1 is 7. We can use that information to answer the following questions. So you're going to notice from here we're going from 4 to 1 instead of 1 to 4. So if going from 1 to 4 gives you -2, going from 4 to 1 will give you
2.
just regular 2. Now on this one, we're going all the way from -1 to 4. So I'm going to make a number line to represent this scenario. So I'm going from -1 all the way to 4. So I have an integral. Remember, we're using f of x only here, so this one's not even going to come into play. I have an integral that goes from -1 to 1, right? And then I have another integral that goes from 1 to 4. So if I want to go all the way from -1 to 4, what should I do? Add these two together. So it's going to be 5 plus -2, which is 3. So everybody see how we figured that out? Perfect. All right, so this one here is the addition property, which means I can rewrite it as two separate integrals. And then in addition to that, what can I do with these coefficients out front?
Put them outside the
Outside of the integral. Yep. And once I've done that, I can now look at what information I have. So I know that f, the integral of f from -1 to 1 is equal to 5. And then in addition to that, I know that the integral of g of x from -1 to 1 is 7. So what can I do with that information?
plug it in.
Plug it in and replace it. So this one's 5 and this one is 7. So that's 31, right?
Wait. Where did I get -5? I don't know. Don't worry about it.
So any questions about that? All right, perfect. Now we're going to look at these two down here. So you're noticing here that we're trying to add an integral of the same function. It's got to be the same function if you're going to try to merge them together, essentially, from 0 to 3 and then from 3 to 8. So if we make a number line that goes from 0 to 8,
Would it just be 0 to 8?
yeah. So if we make an integral that goes from 0 to 8, this one here represents the section from 0 to 3. And this one here represents the section going from 3 to 8. And since there's no gapping, see what I mean by gapping? The one picks up where the other one leaves off. I can write it as one big integral. If there's gapping, that's a whole other story. You can't do that. Everybody understand what I'm saying by that concept? Okay. So that's the same thing. It's like segment addition rule for calculus. Okay. So this one here has us taking from 2 to 9 and subtracting from 4 to 9 away. So visual sometimes can help. I'm going to make a number line from the lowest number to the highest. Yep. So a lot of these you probably can do without one, but it does just help in the sake of learning it. So this one here represents the entire number line. And this one here only represents the portion from 4 to 9. So if we're taking the yellow and taking away the pink, what are we going to be left with?
From 2 to 4.
From 2 to 4. No gapping, so we're good. And that's basically this entire lesson, which is why we're only going to be spending one day on it. And we are not going to go into